I'll share all these with you so that you can. This is the OFDM code. So I'll be sharing this OFDM code. You know, OFDM is used in 4G and 5G networks. It is a modulation technique. It's going to use orthogonal frequency modulation, orthogonal frequency division modulation. So this OFDM transceiver will take care of both the transmitter and the receiver functions. So it will take care of both the transmitter and receiver functions. Now see, we are going to see live example of how to generate a sine wave and see in spectrum analyzer. So you know that you have a component called spectrum analyzer. Spectrum analyzer, whatever in oscilloscope you are going to see, oscilloscope is going to provide you the time domain visualization of any signal. Whenever you are going to, whenever you want to see the frequency domain visualization of any signal, you will be buying a device called a spectrum analyzer. Spectrum analyzer is very, very costly compared to your CROs or CRTs or DSO, digital storage oscilloscope, because you are converting the same signal into frequency domain. So essentially, what you are doing, you are going to take the Fourier transform of the signal, and you are going to see the Fourier transform of the signal in the device called as spectrum analyzer. To see this beautiful example given in MATLAB, I am creating two sine waves. Okay, I am creating two sine waves, one with frequency 100, one with frequency 1000. So naturally, what should be the sampling frequency when you take 100 and 1000? Can somebody type what is the sampling frequency? When the frequencies are 100 and 1000, what is the minimum sampling frequency I should use? When I am having sine wave of frequency 100 and 1000. Please say me the answer for Fs. What is the sampling frequency I'll be using? What is Fs? 2 times the maximum frequency of my signal. What is the maximum frequency here? 1000. So what should be my sampling frequency? 2000. Minimum sampling frequency should be 2000, right? So I'm using 2500 for a safer side. And I'm initializing my spectrum analyzer. So spectrum analyzer, I'm giving all the sampling frequency, number of ports and everything I am initializing. Okay. I'm just running the first code. I explain this, and what I'm doing, I am going to filter one sine wave. So I'm going to design a band notch filter. Notch filter means it will just filter this. It will be at 750 hertz and it will be having quality factor of 35. So further also, I have the MATLAB code. I'm using the DSP block set. So DSP.notch filter, I can give the bandwidth, center frequency, and sampling rate. So I'm going to design a notch filter, and I'm going to give the signal as input to the notch filter, and I'm going to analyze the output. This is what I'm doing, and I'll run this code. You can see beautifully in the spectrum analyzer how the waveform is changing. This is your filter response at 750 hertz, 0.7. You see at 750, the filter is having minimum. Okay, at 750, the filter is having minimum. This is your spectrum analyzer. See, the spectrum analyzer is very good. You are taking the frequency response, right? So I have two sine wave, one at 100, one at 1000. You see, exactly at 1000, I have a peak. Exactly at 100, I have a peak. So I have these two sine wave signal. And now, when I'm going to filter that signal, this is going to be the filtering output. So after I filter the signal, this is going to be the output. So only I have this 100K. I'm not having the second component because I'm going to filter the signal.